Hello and welcome to episode 64 of the eBPF and Cilium office hours, also known as eCHO. So this week, it's eBPF Summit week. We're actually recording this on the Thursday, so we are about to go into day 2. We've had an amazing day 1 so far. I'm looking forward to a really great sequence of talks today in day 2. On day 1, we launched our Capture the Flag challenges, and later today in day 2, we're going to be doing a live solving of what we're calling challenge 2. And in this episode of eCHO, Duffy Cooley is going to be joining me, and he's going to be live solving challenge 3. So if you haven't already seen challenge 2, you might want to go and check that out. Let me bring Duffy into the stream. Welcome, Duffy. Thanks for joining.
Thank you. Yeah, the time travel thing is pretty funny because we're definitely recording this like right before we actually have our long day.
Yeah. Yeah. And we're both in Zurich, as is Tracy, who has been co-hosting the event with Duffy this week and doing an awesome job. Both of you have been amazing hosts for the event. So thank you for that. Tell me a bit about some of the highlights that, what's been amazing for you so far this week.
So, it was definitely, it's great to be here in Zurich again. I really enjoy this city. It's just a really good walking city. It's a great place to just walk around and see everything. And it has this really great kind of diversity of parkland and industrial sections. And it's just tremendous. It's just a tremendous place to be. So I've had a great time catching up with my fellow isovalent employees. I got to spend some time with Thomas and a few others. And then the talks for the eBPF Summit, I hosted last year as well, and I'm constantly amazed at the perspective that people are sharing around all of the technology that we work on. There was a great talk that was talking about kind of the eBPF from the market perspective, right? And they were talking about how what do you call it? People who are going to invest money in VC. Startup companies.
Yeah.
Yes.
VC perspective. Yeah.
Yeah, and I thought that was really interesting. And I thought that was actually a really well-told story. And then, of course, I got to learn a bunch more from Mr. Dan Borkman, which was great, talking about basically his perspective of how eBPF has such a really good integration, or has opened up such great integrations with a lot of the cloud native space, and basically what we can do with kind of that separation between application and Linux kernel. And at the eBPF layer, we can do a lot more than we can do without it. It's pretty amazing.
Yeah, so Daniel's one of the co-maintainers, along with Alexei Starovoytov from Meta, who also did a great keynote. I'm hoping the third maintainer of eBPF in the kernel, Andrei Nekryakov. I hope I haven't mangled his name. And we haven't asked him yet, but I'm hoping that we'll get him along for next year's summit, because it's really great to hear from those people who are really the heart and soul of eBPF in the kernel. And we've had everything. Yeah, sorry, go ahead.
No, it's okay. I was saying I really liked, so in Alexei's talk, one of the things he brought up was he was saying that he was, in his work around the eBPF, in the kernel work, he was trying to find what his mission statement was around how he applies himself to that. And his mission statement was to, enable this in the Linux kernel and to bring others with him, to make it so that it was possible for people to do more with this.
Yeah, to enable innovation. Yeah.
Yeah, and I love that. That's if we all do that, it's the power of community. That's incredible.
Yeah, and then we're seeing people who have implemented and innovated new tools using eBPF, and we're seeing from end users about how they're taking advantage of those tools. So it's been a really great spectrum, and more to come. So yeah, if you're watching and you haven't seen the eBPF Summit videos yet, if you go to ebpf.io/Summit 2022, you will find the whole schedule. All the videos will be linked from there. You can find the slides there already. I think the individual videos will be there in the next few days. You can catch up with the whole day. The streams are on YouTube already on this channel, and we'll add some links into the show notes, which will be on HackMD as usual. So there's tons of really great content to catch up on.
Definitely.
So shall we turn to the capture the flag challenge. So this was the third of our series of challenges. And yeah, I had a lot of fun putting these together. So right. So let's get started. There were some instructions on how to get the challenge up and running. So I think, Duffy, you're going to do this basically from scratch, right? So
yeah.
Do you want to set up the terminal? And if you're ready, I will bring your screen into the stream. So yeah, we can see your terminal now.
All right. So let me just do my checkout here. There we go. So I'm going to check out, I'm using GitHub tool, so GH repo clone of isovalent eBPF Summit 2022 CTF, and that should give me the code. That's interesting.
Oh dear.
Well, I mean, honestly, I can't be not connected to the internet, or you wouldn't see me in this recording. So.
Yeah, that's true. Yeah.
That was weird. That was like maybe a DNS problem or something.
Maybe GitHub.
So there we go.
Briefly disconnected from the internet.
Right. GitHub is down. That would be the perfect GitHub is down kind of situation. So let's take a look at this README file. Challenge 1 we've already done. Challenge 2 I'll be solving later today, and then challenge 3 is. Well, let's take a look at the challenge 2. So you have actually highlighted in the instructions what is necessary. And I thought this was actually well put. So these challenges require a recent Linux kernel with BTF support. We've tested against 2204 in a virtual machine, and we're providing the config for a Lima VM and vagrant file so that you can run this on your Mac, your M1 Mac, and that sort of stuff. Though this challenge is unlikely to work on Linux kit, so running it in Docker with kind on Mac or Windows is not recommended. Now, in my case, I'm running on Linux natively, and my Linux kernel actually has the BTF data. And one way you can find that out, if you're curious if your kernel has it, you can do find syskernel BTF. So these are the object files that hold all of the BTF data. And when you're creating your kernel, when you're compiling your kernel, one of the options when you're compiling that kernel is to have it export this BTF data and have it part of the kernel's effectively virtual file system. So syskernel BTF is where all of that is held. And so my kernel running on this laptop, it already has all this data, so the kernel I have is already supported. So in this case, I can actually just use my regular laptop and a kind cluster. I'll be able to get away with it. The problem with the Windows and the other environments is that when you're running Docker desktop, that Docker desktop is represented by a VM, and that VM may not have BTF data compiled into the kernel running on that VM.
Indeed, yes.
Right.
So you already have a Kubernetes cluster, or do we need to set one up?
Let's get it kicked off here. So kind, create, cluster, big. Do we need Cilium?
We only need one. Yes, we do.
Yeah, yes. So I'm going to leave. Yes. So demos, kind, cluster. So this is going to bring up a 1.24 cluster. It's going to have 4 nodes. It's going to happen pretty quick because all of this is, local images and stuff. And then I'll go ahead and install Cilium on it. And I'll take a look at the config as well.
There's a little pop-up bar. If you can click hide on it, the StreamYard thing. Great. Yeah.
Is that good?
Yeah, that's good.
Yeah, I don't know how much of our border is cutting things off either, but that's something to keep an eye on.
Yeah, seems okay so far.
Sure. So what I'm doing with this kind config real quick, let's just take a look at that. So kind config is basically pointing at a specific image of Kubernetes, just 1.24.4, because I was running into the problems with the latest kind node image, so I just downgraded to a more recent one. And then the most important part of the file is this piece here, where I'm actually disabling the default Cni. And I'm doing that so that I can deploy Cilium on top of it. So if I do kubectl get pods -a, you can see I don't have any CNI. You can see core DNS is pending. That's actually a pretty common way of knowing it. And then if I were to do kubectl get nodes, I also see everything pending, or not ready, I should say.
Yeah.
So let's go ahead and do our Cilium install. And what this will do is I'm just using the open source Cilium CLI to do the install. It's going to drop version 1.12.1 onto the cluster. And then we will go ahead and deploy the work and see what that looks like.
Okay. And this kind config is bringing up 3 worker nodes plus a control plane node. If
That's right.
you use the Vagrant file or the Lima config, that's only going to bring up a single node. And one of the things we're going to need to do is make sure we're looking at whatever node the pod gets scheduled onto. So the challenge is going to be deployed in the form of a pod, and we'll just need to go to the right node. So if you're following along at home and you only have one node, then it's going to be scheduled on that node.
I have git pods-a, everything is running. So let's go ahead and take a look at the README again. And for challenge 2 and challenge 3, so it wants me to follow these instructions.
Near the top of your screen, it says, if you don't want to use Lima or Vagrant, set up a Kubernetes or K3s cluster that uses Cilium as its CNI, and then apply that config.
All right, let's do that. Kernel apply -f. That is the whole thing. Okay. And then challenge 3.
Shall I just bring back the instructions?
Yeah, let's do that.
Yeah, and we can step through these. So this is deploy is complete. Quentin, our colleague Quentin Monet, did a great job writing some background story here. So for last year's eBPF Summit, we had another series of really great CTF challenges, and there's a whole backstory. I'm going to leave viewers to read through this story for themselves, but it's lovely to have this the atmosphere of Blue Hex. Okay, there's a conspiracy in the alliance. The reason we can skip over this is the storyline is really just for atmosphere. So we don't need to try and look through that text for any particular clues.
Okay.
But by now, if I bring back your terminal, hopefully, if we take a look, see what's running. And we should have deployed a pod in the default namespace. And there it is.
And I do see it, yep.
And the instructions say the application running in that pod will tell you what you need to do.
Well, most times when an application is going to tell me something, it's usually going to tell me something via the logs. So let's take a look at that. Go logs. Challenge 3. Hi, I'm Blue Hex. I'll give you an update on how I'm doing every 30 seconds or so. I need internet access so I can learn about eBPF, but I'm getting errors. Boom, boom, boom. Looks like we're trying to reach docs.cilium.io and stable BPF/XTP and timing out. I'll give you another update in 30 seconds. It looks like that's run a couple of different times. So right away, I'm thinking that there is probably something wrong, or something has kind of gotten interesting from the network policy perspective. Or maybe the Cilium network policy. Or maybe, and actually I should have just done that with the whole word. So network policies, that's the Cilium implementation of network policy. So it's a superset. And then nothing there. And then I can also do Cilium cluster-wide network policies, because maybe that, nope, nothing. Okay. So it says that it can't reach the internet. There's no network policies in place. Let's jump into the pod and see what that looks like. So I'm going to do kubectl sec 3 shell. What? Oh,
Yeah, I wasn't kind enough to
All
give
right.
you
All right.
an image with a shell in it in this one.
Very nice. Very well done. All right. kubectl get pods -a, because really what I want to know is I want to know what the network looks like from there. So I'm just gonna get myself into that network namespace and look around. So wide is what I wanted. It's running on kind worker. And so because this is a kind cluster, I basically have 4 nodes or 4 Docker containers that are running all of the nodes. So I'm going to exec in to kind worker. It's kind of like SSHing into that machine, basically the same thing. And then if I do crkettle ps, I can see the CTF app here running. So I'm going to use, because there isn't a shell, and really what I want to know more about is like the network layer. What I'm going to do is I'm going to just use nsenter to enter into that container, but only because you know how containers are made up of like multiple different abstractions, right? There's a file system abstraction, a PID abstraction, a bunch of different namespaces that actually make up any given container. In my case, what I want to see is what's happening on the network layer. So I'm going to use this command, and nsenter -n for network, -t, and I'm actually not going to do that yet, but that's what I'm going to do once I figure out the PID of this running application. So I'm going to do ps -ef. Interestingly enough, I don't think everybody knows about this trick, but if you do ps -e space f, most people just do ps -ef. But if you do that, you get a very different output. See the difference?
For some reason, my mental, my mental hook for that is ps fax, I think.
Oh, okay.
Yeah,
Nice.
also gives you the tree.
Yeah. So this is showing me everything that's happening inside of the process layer, and there is our running container, and I can see that because it's basically in a tree form, right? So there's the container dshim, there's the pos container for the network namespace, there's the application running, and so the PID of the application is 1924. We do nsenter. I'm going to enter into the network namespace and only the network namespace for the target PID 1924. Now, what's interesting is that my file system is still the nodes file system, right? If I do ls etc, for example, I'm still looking at the host's file system, not in the application's file system. But if I do IP link, I am inside of the network for that pod. Now, oh, hey, look at that. This is interesting. So if we look at this output, we can see that there is a program attached. Program XDP ID 3906, and then it's tagged. So likely.
Do you have BPF tool installed? Yeah.
Let's see. We'll save. There's no IP tables. I suspect maybe that's probably our problem. I wonder if that's it. I wonder if there's like in the example, I remember seeing an easy XDP example which basically would just drop all traffic. And I wonder if maybe that's what you've done. That's what I wonder. So in the sake of expediency, I think I might just unload it. But let's see, yeah, BPF tool, I do not have it.
I'm going to check what it is that you need for installing BPF tool, because I think it's part of the Linux common tools. I can probably.
Yeah, I think I could probably pull it in. Install Linux.
Yeah, you need the Linux tools for the kernel version that you want, that you're using. So
yeah, I think in
Linux tools dash, and then with uname -r.
I think in think in Ubuntu there is a apt cache search Linux tools. I think it's common.
Yeah, I think common will give you
the one that's mapped to the kernel I'm on. It's a virtual package.
Try it and see. I thought you have to also install the specific kernel version, but maybe not. I could well be wrong. I think this will allow you to run BPF tool, but it might give you a hint.
Yeah. Look at that. Oh, that's what it was.
Yeah.
So this is the one I was looking at. That's the virtual package I was looking for, because then it will track the kernel that you're on.
Okay.
So install that. Oh, yeah. And actually what's happening, even more fun than this, is because, so this is a container. So the kernel is actually in the underlying host. If I do from under here, BPF tool, list, prog list. So this is all of the BPF data and everything that's loaded up into the system.
So can we see that XDP program?
Probably, but let's see if we can figure out like how to find that. So what I did was IP link show. Interestingly, it's a veth pair inside of a running container. So we're multiple layers of abstraction away. But if I were to do docker exec ti kindworker bash and then IP link show from in here, I don't need the bash part. All right. IP link show. So interestingly, yeah, so this is fun. So in this layer, which is the layer where the host side veth exists, you'll see that there's nothing in this output that describes that there is any BTF data, any XDP program attached to any of these. So do you want to talk about what a veth pair is real quick?
Yeah, I've got a diagram that I can just bring up.
Yeah.
So this is showing us a Kubernetes host, and there's a host namespace, a host network namespace running on that host, and a pod has its own network namespace, or typically it does. And there's this virtual Ethernet connection that connects between those two network namespaces. And the thing about XDP is it's connecting to an inbound network interface. Kind of as soon as the packets arrive, they trigger XDP. So if we were connecting to S0 on the host, it would be looking at or triggered by packets as they arrive through that physical interface. What we've got here is a virtual Ethernet connection, and we're looking at the network namespace for the pod, and we can connect to the XDP interface for this virtual Ethernet interface is only visible from the inside of the pod's network namespace. It's not the host's network namespace because they're isolated by namespace.
Exactly.
But the program is still running in that one kernel. So I think there's something interesting there that we should be able to see it from, we should see the program from the host perspective, but not the connection to the network interface. So I'm going to bring your camera back. Okay.
I'm going to do IP link show again from inside of the pod, right? So now I'm inside the pod. You can see the number of devices I see are different, right? So from the host's network namespace, I can see the Cilium host and the Cilium VXLAN interface, and I can see the host side of the LXC link for this application. And then on the inside of the pod, I can see that there's a program associated with it and that the ID for that program is 3906 and that the tag is FC274AAA. I have this information here. That will be helpful to us when we're trying to find the program with BPF tool. So if I jump back out into the place where I can do BPF tool list or prog list, I'd be able to see all of the programs, but I think there is an option to tell it to show me only the one that I want to see. Prog.
I think it's prog show.
Show. Oh. I think
I'm quite tempted to try and contribute some slightly better help to BPF tool, if I'm honest. Oh yeah, you might need to be sudo for this.
Okay, here we go. So, okay, there we go. ID, program ID. So it would be prog. I think it's going to be prog, BPF tool prog show, and then ID, program ID. And our ID, our program ID is 3906. So we can actually just capture that. And in theory, we should be able to do BPF tool.
You might need sudo.
Say again?
You might need sudo.
So there it is. And can we do dump?
The exilated version will give you the bytecode, and the JITted one is like machine code.
Dump exilated, okay. Yeah. Oh, hey. Look at that. That gives us a bit of a hint. So this is probably dropping traffic. That is probably what's happening. Okay, so let's undo this thing. So let's just get this program off of our network interface, because as you said, the way this is working, this XTP program is written and then compiled just in time, and then you attach it to a certain point, and you could attach it to the Ethernet interface of the host. You could attach it to the host side pair of the VETH, because they're basically two interfaces that just act like a FIFO. Data in and data coming into one side of the pair goes out the other side of the pair, and the same thing in the other direction. So since we've actually attached this inside of the pod's network namespace, we need to basically get ourselves back into the pod. Or I think that would work. Let's try it. So jump back into our pod, it's network namespace. Now, because this is happening effectively at the Linux kernel layer inside of the isolated network namespace, that means that this IP link command is actually letting me interact with and manipulate those devices that are hosted within that network namespace. So I should be able to, from here, do IP link. What is the command? Help. Actually, there's no sudo. Sorry. IP link help. So there is. Yeah. Okay. So IP link XDP help. I think I need to actually talk to that specific device. Yeah, so I'd have to go IP link dev 80 XDP. What I want to do is I want to ditch the XDP connect, the attached XDP program.
Mm-hmm.
And to do that, you need to figure out how it is attached. There we go. There's XDP.
That was part of another subcommand.
Is set.
Yeah.
of ETH0. Help. Okay.
I wonder if there's help for IP link set.
That's, I think we've got. So that's our device, and then we're going to
Yeah.
do XDP, and then we're going to do off. So let's do that. XDP off. Link. Generic? Oh yeah, because it's generic. Yeah, that's the piece that's been turned on. Hey, there we go. Perfect. Okay, so what we saw was, and this is actually another interesting topic. So XDP generic is a way of writing and attaching XDP programs to devices that maybe don't natively support them. And XDP is a way of writing and attaching XDP programs to things that do natively support XDP. So if you had like a 10 gig Ethernet interface from Mellanox, the XDP command is the way that you would attach that. In our case, we're using a different abstraction. We're using like the native kernel layer. We're associating that attachment with XDP generic, which means just the kernel is doing that work. It's not inside the driver itself.
Which I love that, you know, some network cards actually support offloading the XDP program onto the network card. So the whole processing is happening before the packet gets anywhere near the kernel. I think that's really great.
So if I do docs.cilium.io, SL, hey, that looks like docs.
We've got some output there. So we've got interconnectivity.
We fixed it.
Well, let's go and have a look at that application. See what we're playing. See what Blue Hex has to say for herself.
We fixed it. No, we didn't fix it. Oh, hey, there we go. Okay. So it says I need internet access. That was the error state we were getting. And now it says, hey, you fixed it. But I'm distracted by looking at starwars.com. Make me focus on reading about Cilium at docs.cilium.io. And I'll give you another update in 30 seconds. Okay, so let's take a look. I know that there is a function inside of Kubernetes that allows you to define a service type name, and I wonder if you've been creative. Either that or maybe like an environment variable, something in there that would tell me how it was configured so that I could configure it correctly. Because the way I read this, you're saying that, you know, something is pointing at starwars.com, and I need to repoint it at docs.cilium.io. That's how I read it. So let's take a look at that. Describe pod. Environment none. So there's no environment variables, at least that are set from the pod spec.
And it's a good job, because I have to say at one point I considered setting the flags as environment variables, but that would have made it way too easy.
You're not using service type name. And it doesn't look like when I'm in the network namespace, I can reach it. So how are you meant to focus this? How am I meant to keep this from going to starwars.com? That's a tricky one.
Look at a hint?
Yeah, let's look at a hint. Let's see what the hints have to say.
So we had a few hints that... let me bring the right window up. Okay.
I got that one for sure.
Yeah, so we got that. We got through quite a few of these hints. In fact, you already solved the first flag.
Alderon.
I think there were 2 A's, right? Okay, so we got through this part. Okay, we don't have the second flag, so we need help. That is your clue. Networkpolicy.io.
But there aren't any network policies. I wonder if you're telling me to create a network policy. That would be clever. So yeah, let's just go to networkpolicy.io. We'll also look at that log again, just to make sure that we have our error correct. I've got internet access, and I'm spending all my time going everywhere. Oh, you know what? If you read this differently, that makes more sense. So now I've got internet access, but I'm distracted by looking at things I shouldn't be looking at. Make me focus on reading docs.cilium.io. So if I gave you a network policy that only gave you access to docs.cilium.io, then you wouldn't be able to spend your time looking at other things. So let's try that. So what I'm going to do is I'm actually going to make one that says docs.cilium.io. Save that like that. I'm not really particularly concerned with this. And when we do FQDN policy like this, we actually have to turn on the visibility, the DNS visibility. And the way this policy is defined, it's going to drop every other type of traffic. The only thing you'll be able to see is docs.cilium.io. If you try to reach google.com or any of those things, they would not be reachable. So let's try this. Let's give this a whack and see what happens. So I'm going to copy the policy from in here. And then policy YAML. Let's do a little housekeeping here. That's our match name. We can also do a match pattern. The namespace is default. And it's Cilium allow. This matches our definition for the DNS pods because this is a Kubernetes-based cluster, so that's the normal thing. Desktop. And then this is basically turning on the visibility so we can see what the resolved host name is and map it to an IP so that we can then allow this traffic based on the based on the FQDN or the lookup. And then we're only allowing docs.cilium.io. So let's, you know what, let's be a little bit less aggressive with our definition. This will go to anything, this is a match pattern, and it will match anything star.cilium.io, just in case it's not docs or whatever. So let's try that. Let's go ahead and apply this one. And then let's take a look at the logs again.
Okay, we might have to wait for a few seconds. I didn't want everybody running the challenge around the world to flood the internet with too many requests, so it's only going to attempt every 30 seconds. The last thing I wanted was people to be blocked by StarWars.com.
Yeah. I need internet access so I can learn about eBPF, but I'm getting errors, which is a different output.
That looks like what we had before, so that suggests it's not reaching that location.
But it's a different error.
I think it's the same as what we were getting before we removed the XDP program.
Possibly.
I wonder if we should use Hubble or something to see what's happening to that traffic.
Yeah, let's try that. Cilium Hubble enable. Yeah, I don't think it looks like a drop. It looks like it's just not resolving or something. So what I've just done here is I've done Cilium Hubble enable using the Cilium CLI, and it will deploy Hubble relay, and it will actually also turn on Hubble relay inside. It'll turn it on inside of the system. So now Hubble was successfully installed. So now another thing I can do, which I've been actually thinking about making part of the Cilium CNI. You can also do this, which is clever. What this does is it does a kubectl run, creates a pod called Hubble in the kube system namespace, using our Quay.io Cilium Hubble image. And then it sets the environment variables to point at the Hubble relay service deployed in kubesystem. And then it makes it sleep indefinitely. And what that lets me do is now I can just exec into Hubble status.
And then you can run Hubble from in there. Okay, that's nice.
So now I have, and I can see I have connected 4 hosts. I can see that I'm talking to the Hubble relay service and everything looks like it's working. So we can do Hubble observe -n default where our pod is.
Well, that's interesting. Policy denied.
That is interesting. I wonder if I didn't specify the ports correctly. Let's go back to here. Okay. 2 ports. So I wonder if I have 2 ports defined at all. So let's try that. Kernel. Oh, no, here at all.
And the fun of YAML indentation.
Yeah. Policy. Paste. Match pattern. Everything else should line up.
I think so. Yeah.
Keep Kernel apply -f policy YAML. That worked. Logs.
What was that? Another one? That's interesting. Let's see what's happened to. Look at Hubble again.
Status.
Oh, maybe it needs to wait for the request to be made, or would it show a bit of history? I thought it would show a bit of history.
Well, it depends on how long it's going to be. How long is in the ring buffer? But yeah.
Yeah. Okay.
It could actually also be. You know what else it could be? Let's do this. You could all roll out and restart. Oh, but then you're going to have to remove the BPF program again, right?
Yeah, if that restarts that challenge 3, then yeah, the XDP program will get added again by the there's an init container that sets that up. We can probably just check that hasn't. I don't think that pod's been restarted, has it?
No. Oh, there it goes.
Oh, here we go.
Okay. Still getting policy denies.
That's interesting.
Oh, wait. So there's our DNS response. So that is...
Now we're expecting to get denied for requests that go to starwars.com. And now we're starting to see that is because we want to prevent them going to starwars.com. And then we're seeing some requests being forwarded to Cilium.io.
Yeah.
So let's just take a look at the challenge. Output.
So far, this is all DNS traffic.
Yeah.
And then it tries again, and then it tries again. So the drops are all the ones to Star Wars. We're not seeing drops to docs. So the policy is working.
Let's just check the logs again.
Okay. Hey,
there we go.
Okay. Yeah. So I wonder if like maybe your application is caching the resolution of the name, and we had to wait for the application to actually to try to resolve it again, right? So like because like if I turn on this network policy, what's happening is I'm waiting to see the application try to resolve that name in a DNS lookup. And then as soon as it does resolve it, then I can apply policy correctly. But if there's
and that's why in the logs we could see requests to IP addresses and not to StarWars.com. Yeah.
Yes, that's probably it.
That totally explains
fun.
it. Yeah.
Our second flag is Dantooine.
Shall I just
let's finish
bring
up
up
the
the
TypeScript.
thing? Let's do we have the second flag? We do. So type I think it's spelled like that. Yay!
Yes!
Congratulations, Duffy. You solved challenge 3.
Thank you. Yeah, that was pretty clever. I really like that one. I really like that you didn't put a shell in there. One of the other ways I could have actually interacted with that is like, I did it with NSCenter because I'm used to those low-level tools, but I think another way that you could have seen that would be to, if you had a debug, if you were using kubectl debug, you could have attached to the pod that way.
Yeah, that might work. Yeah. Yeah, because you can. Yeah, you can run whatever you want to run.
But I think the big leap for me was realizing that like I wanted to see what the network looked like from the application's perspective. And that's what caused me to jump into the network namespace early. And that's when I noticed the XTP program.
Yeah. And if you can't just exec in, because I think I built the challenge, so it's a little bit hard for me to say what I would have done. But my instinct would be exactly what yours was, to try and exec into the pod and see what network access I can get from there. So I made it a scratch container, so there wasn't any, any shell that you could exec into.
Clever.
So good work thinking about how else you can get into that network namespace. That's awesome.
Another trick I've actually done in the past in situations like this, when there's an image that is missing a shell, but I really need there to be a shell before we had kubectl debug. What I would actually do is I would grab the image and I would do from that image, and then I'd basically take the and I would use it as like a second layer. So I would make a new, I'd do like from APK bash or whatever, and then I would copy everything from that other one in and into the file system, and then run it from there. And that way I could actually use whatever you had built as my base, or as like where I get all the binaries, and then have like Ubuntu bash or whatever be the base image, so I can put more debug tools in. That's another clever way around the problem. But and
I suppose you could build a pod, based on the YAML that I gave you, but also have another container.
Oh yeah, I could have actually just thrown another container into the deployment. Yep, that's a fact.
Yeah,
that's another good one. Yeah, that's effectively what kubectl debug is doing.
Yeah. So if you're watching this and you took any of those approaches, congratulations.
Yeah, nice work. I mean, I really like that challenge. That was a good one.
Thank you. Well, it was a lot of fun putting those together. I hope people who participated enjoyed working through those challenges. And it's fun putting these things together. Maybe we should do it more often.
You're definitely going to see us doing more of this later today, while we do because it's
time travel.
Future.
Yeah, because we're talking from the future, or is it the past?
Coming to you live from tomorrow. Wait, no. All right.
I think we're coming to you live from yesterday.
It might be, yes, that's right.
Okay, well, Thank you so much, Duffy. That was a lot of fun working through the challenge with you. And it's been wonderful. eBPF Summit this week. Thanks to every single person who tuned in, every single person who put a message into Slack. We've really appreciated your comments and participation. And if you haven't already subscribed to eCHO, do hit the subscribe button, and then you can see more of this kind of thing every week.
That's right.
Bye.
Talk to you later.